So yeah, it's good that here come to the last chapter. So we will talk about the wearable device. So after the wearable device, then I will prepare the virtual Peter, and then I will prepare the final quiz, etc., etc. So some of the students ask me about the format of final quiz, right? So the format of the final quiz is exactly or similar to your online and also face-to-face exercise. So there are some structured questions, there are some MC questions, and then most likely it take 2 hours. So is there any really complicated calculation? So I guess the most complicated calculation, it should be summation, okay, or linear equation, summation or linear equation. I think that no more integrations or no more really hard equation that you have follows or you have to do it. So all the things will be easy. And then I will always ask you about the concern point, or I will always ask you about which one is better, etc., etc. Try to put more understanding or try to study more on the online exercise and also the face-to-face exercise. So that it helps. It helps. So yeah, that is the format that we are going to prepare. And after I have prepared all the online quiz, all the final quiz, all the questions, then I will try to type in something to guide you for the final quiz. So that is my performance, and then I will try my best to help. And of course, I will prepare the virtual Peter, and yeah, I will prepare all this kind of script, put it into our conversation AI or into a web interface so that you can easily to connect and then discuss with virtual Peter. Try the questions, try the answer, and the virtual Peter will become one of the standards for your revision. So yeah, that's the settings. Of course, if you cannot wait for the virtual Peter, so I have mentioned at the very beginning, the best way for you to do the revision in the university under the AI age is upload all the materials into the Gen AI and then ask them to generate some past paper, or you can also download the past paper from the library as an input to put all the things into Gen AI and ask them to generate some new I always say that what is the hot topic or what is the most important or frequently asked questions in this exercise. So it helps your study. So yeah, as a university student, it's really hard to ask what is the broad and then what is the depth of your study. We can only answer, yeah, we recommend you to study 2 hours to 3 hours of this course per week. So that is our setting. So and this is our course setting. So for all the video exam, remember, so our recording is around 2 hours, something like that. So if you just do the online exercise together, so the total hour will be 3 hours, and that is our settings. And then yeah, if you come to the lab, face-to-face lab, so most likely we'll discuss the answer and then let you know. And of course, we have one more wizard. So this wizard helps you to experience more in the wearable device. It also lets you to relax, become more relaxed in the end of semester. So I guess you need not to put so many effort in our subject, and yeah, still you can get a reasonable score. Or we'll try. And then yeah, of course you have to study. Of course we have when we have 300 students, right? When we have 300 students, so most likely we can have a long mode distributions, and then we try to manipulate the long distribution to say that B or yeah, B minus, and yeah, hopes that it helps. So before everything starts, yeah, it's good that let us have a look with a videos, and then we know what is the wearable tech.
So, do you know those super fancy sci-fi movies? You know, the ones where they just tap a badge to teleport to another world? Or project a cool hologram from their watch? But futuristic things like that aren't so futuristic at all. You can actually get some of those sci-fi accessories already, like smart bracelets, rings, watches, and even glasses. These are called wearables. There are bracelets that connect to your smartphone and display incoming messages or calls.
Hello.
Oh, hello. Google invented the first pair of smart glasses, which you activate by saying, "OK, glass." It can take pictures, give directions, and even translate your voice. And sick of always losing your TV remote? Well, those days are over. There's a ring that recognizes what you write in thin air. This way, you can turn on the TV and even dim the lights. But not all wearables are just for fun. Scientists are working on contact lenses that monitor blood glucose levels in your eye, which can be life-saving for people with diabetes. So you just sit and wait. Soon you can beam yourself to another planet. Awesome.
So the first wearable device is fitness tracer here, fitness tracer. And then the fitness tracer, yeah, this one, fitness tracer. So it's here. So if you heard about Nike Plus, so it's the first fitness tracer. So a small sensor installed inside your shoe, and then for each footstep, okay, for each step. So it counts for one, and then connect with your mobile phone, and then connect with your GPS. So somehow your mobile phone have a GPS, so they match all the things together and then trace your movement. So especially for the PT, so if you're asking for tracing the physical exercise, this kind of Nike Plus will be the first one to do the it's a wearable device to trace the physical movement. Then later on, we have lots of the smartwatch. So Apple Watch or somehow about the Androids, they also provide similar settings because install something inside your feet. So you need to you need to charge them, and then you need to put lots of the sensor inside your shoe. It will be a little troublesome. So we have the smartwatch, and then smartwatch they have the accelerometer that we have discussed in the VR, AR accelerometer, and also gyroscope. So when you swing, this one swings your hand or when you're running, so somehow the accelerometer and also a gyroscope change, and then this kind of the sensor will transmit will simulate your physical exercise and then transmit the signal back to your mobile phone. Later on, the smartwatch also install lots of different kinds of sensor. For example, you can use the smartwatch to trace your heartbeat. You can use your smartwatch to trace different kinds of the biometric marker of your body, and that is I would say that the second generation of the wearable device. Later on, we have different kind of things. For example, the watch you need to charge every night, right? Every day you need to recharge. And then is there any better solutions for the wearable device? And then there is a ring here, just a ring. A ring, they have the similar sensor, gyroscope, and also some heartbeat sensor to trace your heartbeat, to observe your biometrical data, to put the biometrical marker into the mobile phone and synchronize. And of course, today there are lots of smart config. So for example, you install something, for example, you have the heart disease, and then you install some multiple sensor to near your heart and then trace your heartbeat. So that is the smart config. And then, yeah, you can put it anywhere else and then sense your body movement, especially about your biometric marker, especially about your heartbeat, because this one is really important. For example, if you have the heart disease. So lots of the cardiology and then lots of the doctor, they recommend this kind of smart config. And last but not least is the head-mount display. So if you remember in our previous slide, so we have the Google, right? We have the Google glasses. Yeah, Google glasses. So that is the first head-mount display. And then there are really small projector. So they have the camera and then chase the surrounding. And then they also have the speaker. They also have the microphone to have the audio input. So with the visual and the audio input, and then they will have the computation power and then connect with your mobile phone. And somehow they will project the image to your glasses. And this is the first head-mount display. Of course, right now within this field, I would say that Google Glasses is almost 15 years ago, right? And after 15 years ago, so the AR AI glasses become hot again. So in these few months, so you have lots of the sensor from Rockets, yeah, Rockets, and also Meta. So they have the AI AR glasses. So they also combine this kind of AI tooling with the projector, and then it's a head-mount display to your glasses. So that is yeah, I would say that is the 1, 2, 3, 4, 5 main category of the wearable device. So the whole process of the wearable device can be summarized into this line, this graph. So to be easy to understand, the whole process can be divided into three parts: wearable sensor, computing, and also the application. So the wearable sensor somehow is about the electronic device. So there are lots of different devices. It may be light sensor, it may be a physical sensor to scan different biometrical marker, biometrical information. So it may be your heartbeat here, ECG. It may be your brainwave, EEG. It may be your muscle level, etc., etc. So all these kind of the biometric marker will be captured by the sensor, and then the sensor, they will transfer all the things into signaling. Easy understanding is your habit. So this one is the signal, right? Is the signal. So throughout the signal, we will use this different kind of the, I would say that if you still remember, so you have the integration and differentiation. So we have the differentiation and then one the FFT, fast Fourier transform, this kind of the equation, and change this kind of the biometric marker signaling pulse into something that is readable or something that is meaningful to our human sense. Because if you just reading the signaling from the sensor, honestly, it's really hard to observe whether you have the heartbeat or whether you are doing the exercise, whether you have the heart attack or whether you are doing the exercise, etc. So by using the fast Fourier transform or DFT, discrete first transform, that means the integration, differentiations. So somehow it will be changed into some good, understandable signal processing. So we from the biological information to the signal processing. And then throughout this kind of signal processing, we will match with different observations of our human. For example, we find lots of the expert to label, hey, this one is exercise, 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 just like our machine learning algorithm. So we find lots of the people to label this kind of the marker, this kind of the signal. So we match them into somehow about machine learning level. This part, yeah, here we can use the AI, right? So AI match into the if then else would, if we can find the expert to label, hey, this one exactly, this one is the doing exercise, or somehow we just label the input and output process, right? Just put the label and then use the machine learning algorithm. So here, two parts. So you have the rule base, and then you also have the machine learning level. So after this one, then you will go to the system or application. Yeah, this one, edge computing. So I would like to point out one more keywords. So honestly, this kind of the model or algorithm, so you can send to the cloud server, or if you remember, so you have tried the Hugging Face, right? Hugging Face or Google Teachable Machine. So those are the cloud service, PaaS, Platform as a Service. But somehow, this kind of signal, we don't want to transfer all of the information, all this kind of information to the cloud service and then do the processing. So we will have the edge computing. That means we put some of the calculation, some of the, I would say that some of the algorithm into your small device, okay, into your small device, and then let them to process easy. I will say that let them to process a little bit and then send the output to the cloud service. So that is called edge computing. So after you have the computation, you have the modeling, then you can go to system and application. System and application go to different dimension. Perhaps you need a HCI, human computer interface. For example, you do the apps or you do the web interface to display all the things. So human-computer interface or human-machine interface to display all the things. Then you can think about the application. Perhaps you are doing the here health monitoring. So you observe your sleep, you observe your exercise, you observe your step, etc., etc. Maybe you want to promote the physical exercise, so you create some games for them and then let them to do different kinds of applications. Maybe it will relate to your disease. So somehow maybe you have the different lives. They observe the diabetic. They observe the blood sugars of your body. So you will have the disease diagnosis and then to identify whether it's suitable or not. Some of them they go to robot. So today there are lots of service robot, right? Service equipment for you to handle different kinds of the manipulation. So that is the system and application area. So another example, when you are using in the elderly, for example, I want to observe the physical exercise of the elderly. So we will have the see that this one is the smart control inside the shoe. So just like the Nike Plus, then we will have the app to monitor the situation of their moving. Okay, for example, you want to observe their physical exercise, or honestly, if you want to observe their mild cognitive impairment or this kind of thing. So we can observe their balance gaits. So you can have a brief understanding, PT, right? You are PT. You have a brief understanding about how this kind of the process can affect their walking cycle or can affect their running cycle. So MCI affect their running cycle, MCI affect their walking cycle. So this one, app monitoring is also good. Then you will go to some rule-based. For example, here you have the full control. It will return to a rule-based system, and then to identify whether I should provide the additional information or additional health advice to the elderly or not. Or somehow if it's good, yeah, here is the if then else, easy to understand. If he's good, then it's okay. We do nothing, or somehow we give them a little bit monitoring on their health, or if they are at worst. So somehow we have the feedback system. So the feedback system, so here, for example, the earphone, we will give them some advice. Hey, you need to stop, or you need to call for help, etc., etc. So those are the applications, and then how the wearable device can be used, and then to apply into our health process. And then the whole path goes like that. So always remember 3 steps: wearable sensor, and then you have the computing, you have the computation power, and finally you need to match with your system or application. 1, 2, 3, 3 steps. So what else about the wearable technologies that we will experience in our daily life? So let's have a look with more example. So maybe first one will be here, wearable assistive technologies. So it's designed for the disabled, it's designed for the impairment. So for example, easy to understand will be visual impairment. So for the smart glasses, for example, here we have a lot of the AI, AR glasses. So they can understand scene understanding, segmentation, and then scene segmentation, and then scene understanding, and also the object understanding. That's why, or that's what we have discussed inside the AR technologies. So it can help lots of the visual impairment people to understand the current situation by using the camera and then the audio output. Some of them may be a wearable exoskeleton. So for example, you lost your arm or you lost your leg, etc. So you have some wearable device to install inside your arm. For example, I will observe the signal of your arms or the signal of current with the gases, the signal of current situations. Then I will try to use this kind of the signal of your body to control the robotic arm. Whether I can grab, yeah, here, where is the, yeah, whether I can grab the object, or whether I can control the, I would say that's wearable exoskeleton very well for the mobile impairment. We also need to have the feedback. So somehow, if you say that, for example, I want to grab this gas, right? So without the feedback, I cannot control when I should stop this kind of actions. So we need the feedback system to go back to our the other parts of the body so that we can feel. Because one of the most important things of our sensory system is our haptics here, haptics, and then the haptics. So they give you lots of the information about our whole world. So not only about this kind of safety technologies, for example, we also integrate a lot of with the Internet of Things. Yeah, many years ago, if I remember, the inventor of IBM say so. They always say that, hey, I cannot imagine a world with more than 5 computers. So nowadays we will think that, hey, I cannot imagine a person without more than 5 devices that is connected with the internet. For example, today when you are go outside, so most likely you have the mobile phone connected to the internet, right? So it's Internet of Things. It's easy to understand. Your smartwatch, maybe your smartwatch also have the 5G card, right? So they are always connected with the internet. Maybe your tablet, maybe here my ring, maybe your AI AR glasses. Maybe you also have different kinds of device at home, PS5, notebook, etc. So all of them, they are Internet of Things. That means they are the wearable device or electronic device that is connected to the internet. With the connection with the internet, so somehow all these kind of device they can communicate with each other. So they are well connected and then well communicate with each other. So we can also do the health monitoring, observe the biometric marker, and then, for example, this one we are observing the blood pressure, we are observing the heart rate monitoring, and also the oxygen level. And then they are using the ECG, electrocardiogram capacity. So by using this kind of the sensor, we can chase lots of the informations about your, I would say the vital information about your body. So those are things are called biometric marker. Of course, we can use the gyroscope and then also the gyroscope and also the accelerometer to chase the um, to change the fitness, to change the number of steps that you or distance calorie burns that you have do. So we are tracing their physical exercise. So this is advanced fitness tracing. And then, there are lots of the people they are wearing their smart clothing. So the fashion tester, especially, as I remember, in this 1 or 2 years, school of fashion tester also jump into this kind of technologies and create lots of this kind of smart clothing. So you try to display your capture and also display your health information and also with your muscle activity. And then there is a new master about this kind of smart clothing. My expertise, VR and AR things. So wearable device, VR, I would say that go to your homes and then Orange, Microsoft, Vision Pro, Apple, and Oculus, and then Pico, etc., etc. So they go to your home and then try to do lots of the, I would say that additional information to your entertainment and also to your physical exercise. AR go to your normal life, daily life. So they provide the AR AI guides, and then for your immersive gaming, training, entertainment, and also lots of the immersive exercise. So some of the today, if you are OT, right? So some of the experts, so they try to connect lots of the electrocardiogram and then to match this kind of signal with some mental health problems, especially about the depressions or anxiety. So this kind of two things is the major. So they observe the signaling, and then they find the expert to label, hey, this is the actions of depression, this is the labels of the anxiety, and then put it into the machine learning levels, and then let the machine learning to learn the patterns of the signaling. And that is the wearable device for the mental health. So honestly, you will say that, hey, is from the I would say that basic science, and then we can observe from the basic science, and then we can observe the biometric marker. The situation is not like that. It somehow we have the observations about their mental health, and then we have collect a certain of the signal output. So we try to find the algorithm machine learning to match them together, and they become the wearable device for the mental health. Yeah, that we have set exoskeleton. So, for example, for the disability. So today the exoskeleton. So somehow it's not only about a wheelchair. It's not only a joystick or a button. You control all the electronic device by just, I would say that just like a Gundam or just like a you are paying PS5. It's not like that. So today when you are looking at Brinko, one of the very famous company Hangzhou, China. So somehow they use different kind of biometric signaling, biometric information to control the exoskeleton. So not only about, for example, you broke the arms, right? Not only about the bones of this part. So they also understand the muscle, contract of the muscle. They also understand the EEG. They also understand the environment setting. So they use the multi-model model to control the exoskeleton, and that is the new device. So we are not only using the single output, or we are not only using a button to control or joystick to control all the things. We try to get more and more biometric information and then try to improve this kind of the, I would say, the assistive technologies for the disabled human. And let's have a look with the videos.
Robot, stand up.
This is 16-year-old Oscar Constanza and his dad, Jean-Louis. Jean-Louis.
Robot, stand up.
This is 16-year-old Oscar Constanza and his dad, Jean-Louis. Jean-Louis built this robotic suit that walks for Oscar, a wheelchair user.
This is new for me because before to walk, I've always had assistance. And now I no longer need assistance, so now I feel independent.
Jean-Louis co-founded the company that builds the suits.
My son Oscar, one day he said to me, "Dad, you're a robotics engineer. Why don't you make a robot that will allow
So
us
honestly,
to walk?"
right now, this
The
kind
suit is
of
currently too heavy to be sold for personal use.
arguable. You will always say that, hey, if
Jean-Louis
they are
built this
disabled,
robotic
why
suit
don't we just produce a wheelchair
that
and
walks
then they
for
have a
Oscar,
joystick,
a wheelchair user.
forward, backward, left, right, etc. So it is more trustable, right? So
This
it's
is new
more
for me
reasonable.
because before to walk, I've always
can
had
fully trustable.
assistance.
But honestly,
And
this kind
now
of
I no
exoskeleton
longer need
is more
assistance, so
complicated,
now I
it's
feel
difficult,
independent.
it's expensive, but it will build the
Jean-Louis
confidence for the
co-founded the
disabled
company
people.
that builds
So
the suits.
walking
My son
for the
Oscar,
disabled
one day he said to
people,
me,
so you will
"Dad,
rebuild their
you're a
confidence.
robotics
You will
engineer.
give them,
Why don't
hey,
you
I
make a
act
robot
as a
that will
normal
allow
and
us to
someone
walk?"
care about me.
The
So not
suit is
only about
currently
their
too
physical,
heavy to be sold for
I would say
personal
their physical
use,
needs, we also need to care about their mental needs.
but dozens have been